Have you ever wondered how your GPS just knows the fastest route? Or how following a recipe can somehow create a perfect cake every single time? Well, today, we're going to pull back the curtain on the secret sauce behind it all. We're breaking down two of the most important ideas in problem solving: algorithms and flowcharts. Let's dive in. So, let me just ask you something to get us started. Have you ever followed a recipe to bake a cake? Or maybe put together some IKEA furniture using the instructions? Even just following directions to a new restaurant? If you've done any of those things, then hey, congratulations. You've already used an algorithm. See, it's not some big, scary, complicated term that's only for coders. It's something we all use all the time to get stuff done. Because at its heart, that's all an algorithm is. It's a set of steps, in order, that you follow to solve a problem or finish a task. It's your game plan. It's your to-do list. It is literally just the what to do part of the equation. But here's the thing, for any plan to work perfectly, especially for a computer which takes everything you say literally, it has to follow a few simple rules. Think of them as the rules of a good recipe. So, a really solid algorithm has these 5 key things going for it. First, precision. Every step has to be crystal clear. No add a pinch of salt. We need exact measurements. Then, there's uniqueness, where each step does one specific thing. Finiteness is a big one. It has to actually end. You can't just bake a cake forever, right? It also needs a clear input. Those are your ingredients, and it has to give you a clear output. That's your delicious, finished cake. Get these 5 things right, and your plan is basically foolproof. Okay, so having a written list of steps, that's great. But you know what's often even better? A picture. What if we could actually draw our plan? Well, that's where our second big idea for today comes into play. A flowchart is exactly what it sounds like. It's a diagram, a visual map of your algorithm. It uses simple shapes and arrows to show you the flow of the instructions, which makes it super easy to see the whole process from beginning to end. If the algorithm is the recipe, the flowchart is the step-by-step picture guide that comes with it. And to draw one, you really only need this basic toolkit. Ovals are your start and stop points. Rectangles are for actions, the doing parts like mix the flour. The diamond shape is your decision maker. It asks a yes or no question, like, is the oven preheated? And those parallelograms, they just handle stuff coming in or going out, like getting the ingredients or serving the final product. Simple as that. And just like our algorithm, there are a few simple rules to keep our flowcharts clean and easy to understand for everybody. The main goal is always clarity. You want to have the flow go from top to bottom, make sure every action has one path out, and every decision diamond has 2 paths out, a yes and a no. This way, anyone can look at your diagram and get the logic in a heartbeat. All right, that's enough theory for now. Let's actually put these 2 powerful tools together and see how they work in the real world with a practical example. Okay, so our first challenge is a total classic. How do we make a plan for a computer to figure out if any number you give it is even or odd? First up, we write the algorithm, our step-by-step plan. So step 1, start. Step 2, get a number. Then step 3 is the key. We check if the number, when you divide it by 2, has a remainder of 0. If the answer is yes, well then we know it's an even number. If the answer is no, it's gotta be odd. And then we stop. See, a perfect logical plan. And now, here's that exact same plan, but as a visual blueprint. Now, I know there's a bit going on here, but just focus on the flow. We start at the top oval, we get our number, and then we hit that diamond. The diamond asks our big question: is the remainder 0 when we divide by 2? From there, the path splits. If it's yes, we follow the arrow to print even. If it's no, we follow the other path to print odd. And notice how both paths lead right to the final stop oval. It's a clean, clear visual journey. Awesome, you're getting this. Let's do one more just to really lock it in. This time, calculating simple interest. The math is a little different, but you're gonna see the exact same logical structure at play. And here's the flowchart for it. Again, just look at the structure. See how organized it is? We start by getting our inputs, the principal, rate, and time. Then the rectangle shows us the process, the actual calculation. And finally, the output is printing that result. This is why flowcharts are so amazing. You lay out the entire plan visually before you ever write a single line of code. It helps you catch mistakes and makes everything way more efficient. So, as we start to wrap this up, I want you to think about this as more than just a computer science thing. What you've really learned today is a kind of secret superpower for solving pretty much any problem you can think of. So here it is, the key relationship to always remember. The algorithm is the brains of the operation. It's the logical, step-by-step plan. And the flowchart? That's the blueprint, the visual map that brings that whole plan to life. You really need both to go from just an idea to a clear, actionable strategy.
You know, it really all boils down to this one simple, powerful idea. An algorithm tells you what to do. A flowchart shows you how it's done. Just let that sink in for a second. That distinction is at the very heart of how we solve problems in a structured way.
By getting a handle on these two concepts, you've learned how to break down any challenge into small, manageable steps and then visualize the entire path to a solution. So I'll leave you with just one question. Now that you have the tools to create a plan and visualize it, what problem are you going to solve next?